Alright, draft physics video. Yeah. So unfortunately I have to waste some time on comments. It usually is a waste of time. Anyway, and then I'd like to get to gravity and build the Hilster, the older Hilster. Anyway, I did another video. And there's just not enough details in these particle theory. It's a 300-year-old idea, and it really was talked about by a lot of very famous people. And there was it's obviously there's subtleties to the physical universe in the sense that we find out it has these certain properties and certain rules, and you have to conform to those rules. And as we develop more and more rules, you have to refine a theory more and more to fit those rules. And there really wasn't any other theory, any other material explanation besides this particle theory before Einstein's amazingly bizarre, in a sense, non-materialistic bent ether theory. So there really wasn't any competition. And the funny thing is, the Einstein theory is essentially the same exact thing as the particle gravity. It just has a different, it's just reversed. So to speak. It's it's the push versus the drain pull kind of idea. But anyway, we'll get to some of that maybe if I can get through this crap. Alright, so a Frank Docker. I now know why no one debates EU. That's the electric universe. They come off looking like fools. Wink. I don't know the point of that comment, so I'm going to delete it and just say fuck you. Yeah, I don't see the UE people, EU whatever. I don't see them looking for a challenge. And clearly I just played the guy's video, so I mean, I don't know how I can come off looking silly when they're talking about the electric angels come to save mankind. I mean, it was sappy, childish mush. So anyway, universal expanse. Yes, there are so many so-called educated people who have the brain of a pea. Yeah, well, that's not very useful, but whatever. Chili sauce. Post a link to some flat earth video. I should just fucking block you for that. I'm really not here to discuss flat earth theories. 34-mile diameter suns that are 3,000 miles away, and they think every single millions and millions of people are on a gigantic conspiracy to fool people into not thinking the poor earth is flat. I mean, it's just so fucking stupid. You really should be shot for even referencing it in print. It's just so stupid. Anyway, more debunked videos, please. Unexpected, entertaining. I'm not here to entertain you, but whatever. Alright, so now to the you suck guy, who is now, obviously I'll block him because he's just such a fucking, troll. Anyway, a reference frame, aka an inertial frame, is a coordinate system. Like, this won't have anything to do with the video it's posted on, by the way. That's just a definition. So for example, a given reference frame, I love that, bijection between points of your reference frame and symbolic points of a form A, B, and C, where 0, 0, 0 is chosen arbitrary, but it is fixed and stays that way forever and ever. Unfortunately, there's no way to stay that 0, 0, 0 for you is going to be 0, whatever. I don't know what these zeros have to do anything. If someone else is in a car, then at 10 at t0 we could say some point xyz in their frame corresponds to your 0, 0, 0, but that will change as a function of time. Do you understand this concept? No, I think the whole idea of you saying things have frames, or they're bending space, and that's the same difference. and there's a bunch of bent space around them, bent time. It's just plain made up bullshit. No, question mark. Read it again. No. Look up the words. No. Good. Now, can we continue? No. I mean, it's a silly, unproven theory. You want to believe it, you go ahead and believe your fantasies. It's a unicorn theory that you think everything corrupts the entire universe around it by moving through the universe. It's just an ether theory, for fuck's sake. So, fuck you. You're silly. Why do you assume that light travels at fixed speed? I don't assume it. There's just so much fucking evidence for it. In one and only one inertial frame. I don't believe in inertial frame. So again, I just don't care about your silly notions that the universe has a bunch of crooked stuff everything's bending time and space. It's just stupid. Why not all inertial frames as Einstein conjectured? Why would you assume a light fixed speed and only one inertial frame? Question mark. Why not all inertial frames as Einstein conjectured? Because the fact is that two things do move towards each other and shorten the distance between them. And there's a consequence to shortening the distance, and that is the stuff will travel that shorter distance in a faster amount of time, and it's just the truth. That's how you're going to perceive it. But you're just perceiving it that way. The distance was shortened. Time didn't warp, space didn't warp. You shortened the distance. I mean, you perceived the two cars passing. Car 30 miles an hour, car 60 miles an hour. No car 30 miles an hour, car 30 miles an hour. They perceive it as 60. The perception isn't a reality. No car is going 60 miles an hour. I mean, fuck. Anyway, that is just an assumption. Yours is an assumption. You don't have any evidence for this shit. From whence did it grow? Well, from whence did your silly everybody's bending reality? From a naive understanding of reality. That's what I would say you have. You've made some observations. You noticed how birds fly, how cars travel, and you made a conjecture based on those observations. Well, that's pretty much rational, actually. You look at all the evidence and say, which way does the evidence point? Is there a ton of evidence for the bent ether medium space-time? No, there's not a ton of evidence for it. There's not any evidence for it. When new observations seem to contradict those assumptions, you decide that the observations are wrong. No, you're saying that when you do a preposterously technical experiment and claim you can follow photons from here to there, 15 meters away, and you're following the same exact photon, and say you can do all kinds of preposterous things in your experiment, somebody might be rational and say, well, how do you know you can do all this shit you think you can do? That's why you are wrong about physics, and that is why you are getting such negative feedback. Now, I'm getting negative feedback because you're all religious kooks from many quarters regarding your channel. It's not many corners. It's the same ill-informed douchebags like you who haven't really watched the videos. You haven't watched the lectures. You really don't understand the mechanics and how mechanical explanations can describe everything that's happening. You don't need any of this woo. Does that seem clear? Does that seem clear? Just thought I'd take the time to help you understand. Well, you can go fuck yourself until dead, you piece of useless suck. At least he titled himself properly. Anyway, so you suck again. Why is reality obliged to conform to your dumb ideas about how it ought to be? So again, this projection, that if you argue that if you take a glass of the ocean and you drink it and you say, ooh, salty, and you do that 500,000 times, ooh, salty, that you shouldn't conclude that the ocean is salt water and that's what it is. No, that would be stupid. That's a fallacy. No, fuck you. It's called the is-ought gap. Well, there is no such thing. I mean, unless you're incapable of composing is statements that have value connotation. So if you can't make an is statement like torture is bad, then yes, you have a gap. But as soon as you say something is good, or as soon as you say something's bad, you've automatically indicated an ought. That we ought to do the good and you ought not do the bad. It's kind of obvious. It's in the nature of the word good and in the nature of the word bad. Those words can't exist without that value connotation and with that ought obligation. They don't have a rational definition otherwise. So you're the one out of luck, asshole, but you're too stupid. Something you have yet to wrap your feeble mind around. Well, like I said, you haven't wrapped your nihilistic, self-obsessed, insane, and I will say psychotically insane. I mean, if you can't say torture is bad, torture is bad, and that torture ought not to happen. If you can't do that, you're really dumb. Like, especially dumb. Alright, so all this philosophy and this physics video is just more a part of this rudeness of this cunt. You suck again. Alright, the is-ought problem, okay, it's not a physics problem, is articulated by Scottish philosopher and historian David Hume. Who the fuck could care? Me? No way. States that many writers make claims about what ought to be on the basis of statements about what is. Yes, that's right. You identify what something is, and oughts are always an obligation of any value statement. Hume found that there seems to be a significant difference between positive statements about what is and perspective or normative statements about what ought to be. And again, there is absolutely no disconnect between recognizing something as having a quality that's better to replace some negative quality, and that it is not obvious how one can coherently move from a descriptive statement to a perspective one. I don't see how it's in the nature of the word good and bad. There's no way to avoid the ought. The is-ought problem is known as Hume's law. Yeah, fuck you. Or Hume's guillotine or something, whatever. This also works in another way around. The ought-is gap is in many, may be dubbed, I don't know, the Oz-it gap. Like, that makes a lot of sense. So then somebody responded to him for wasting their time. I suppose the is-ought gap nonsense is your comment is just relevant to the subject of this video, and whatever. Yeah, anyway, so yeah, it's not relevant quite obviously. Alright, so last one by the suck. It's amazing to me that anyone would be an anti-natalist. So he's bringing up a completely, subject completely unrelated to these physics videos, and not understand the is-ought fallacy. I would argue that the is-ought fallacy is the fallacy that there's some sort of is-ought gap. I received the following feedback, which inexplicably got one thumb up in regards to one of my previous comments. The supposed is-ought gap is nonsense, and your comment is not relevant to the subject of this video. So he's reposting the same comment section from below. To the person that posted this insanely moronic response, first of all, acknowledge you're a moron. Well, that's just too special. And I don't care if it's relevant or not. I like getting off topic. Well, good, do it someplace else. Secondly, recognize that the is-ought fallacy means literally that making an argument of a non-normative value for a more normative value from the mere description of how things in fact are is a fallacy. Well, again, I think it's just idiotic to acknowledge you've recognized something as unproductive, inefficient, bad, destructive, evil. You could even expand the single words to their actual definition, which is something that should be prevented, which is probably the definition of many of those kind of words. And you can't figure out there's oughts tied to that. That's just too moronic. If I made an argument people have children, they like having children, and therefore having children is morally permissible. But again, did that cover the subject of what having children is? That's like saying, I like killing people. I really would like to do it. Does that mean killing people is good? I mean, this doesn't make any sense, because I enjoy killing people. I should be allowed to kill people, and it's morally acceptable to kill people. That wouldn't make any sense. I'd actually like to torture people like you, because you don't seem to understand what torture is, and I'd like to educate you into what torture is. You know, I'd like to pull out a few of your toenails and shit, just to give you some, you know, it's like reading you a book, right? It's just teaching you. Let's see, therefore children is morally permissible. Have I committed the is-ought fallacy? No, you've been trivial. You've committed the you're a trivial cunt. You can't seem to be able to develop a counter-argument that's not a fetus. You don't, you know, your argument is so immature and undeveloped. You clearly have to make an argument in the real world. In the real world, there's all kinds of trade-offs. So when you do declare something bad, you have to be kind of sure that you've analyzed it a little bit. So if I say torture is bad, I don't mean torturing assholes is bad. You know, I just mean that torture in and of itself, without any assholes getting tortured, is bad. Dumbass. I mean, it's all got to be qualified. If I argue that nations have always warred with one another, and that therefore war is morally good, I have committed the is-ought fallacy. No, again, you've been so trivial. No recognition of the total cost. So to say because somebody profits, everybody profited, would be idiotic. Clearly, sometimes one person profits and a million people lose. So you have to understand the real equation, idiot. I'm surprised this is so hard for you to understand. I'm surprised, well, I know you do know that, and you just don't care. The truth is irrelevant to your fanatic religious proselytizing for your Nietzschean, I don't give a fuck and I don't want to give a fuck and I don't want to have to obey any rational rules. No matter how disappointed I may be at a given moment over people and how stupid they are. Yeah, well, I'm definitely glue on that subject. Yeah, I feel the pain of stupid fucks. There's always seems to be someone else who comes along to disappoint me even farther. Yeah, well, like I said, you're just walking into it with that kind of nonsense. Like you give a shit about anything except you. It would be fallacious to say something, okay, this is somebody arguing with him again, something ought to be some way because it is currently is that way, as an example you used. Well, it's not because it's currently that way. The example is superficial and doesn't calculate all the real costs. But that is not all that's meant by the supposed is-ought gap. The is-ought gap argument presumes that oughts are just expressions of personal desires without basis to say any of them are more or less correct than any others. This is a nihilistic philosophy. Well, that's certainly the... obviously any religion can take an idea or a theme and grab it for their own. So there certainly are, what do you call those, Methodist, Protestant, Catholic versions of nihilism. I'm not going to continue arguing philosophy here. Your liking to go off topic doesn't mean you ought to. Quite obvious, yes. Just more rudeness from more rude people. So, not much you can do about it. Say, fuck off. Cowboy did, you know, closed his channel, his cowboy channel, the last one, whatever, by his real name or whatever name it is. So he's got some other sock accounts, of course, but he did delete his shitty videos. For the record. Anyway. Alright, so that wasn't too painful. Alright, so let's do some of this gravity talk and such. Okay. So, this is the Elder Hissner. I don't know why I'm calling it Hilster. Jeez. Anyway, so I'll just jump through, maybe just even the, you know, it's all done in a presentation.
My name is Bobby Hilster, and I am.
Yeah, you know, it's all done in this, whatever you call that kind of form. but there's no real depth to it, so unfortunately. And so it's basically a particle model, except he's got two kinds of gravity, sort of in the sense that mine has two, okay, types of particle, but the only difference in their type is polarization. It's a tiny difference. His are on a huge scale of difference. So the G1 particles would be like the size of the sun, and the G2 particles would be like little baseballs, something like that. And so he has particle-to-particle interactions, which is really dangerous. But anyway, pass through, no effect. Bounce off, will push and be pushed. This is where you really get into trouble, because you have to decide the elasticity of a gravity particle. So you have to, and he just doesn't deal with any of these. The thermodynamic problems have been around from the beginning, and actually the Wikipedia page has gotten much better than it used to be. I think I have it somewhere here. I mean, it doesn't have any of the external links that it used to have, that they deleted when I tried to augment the page. But anyway, they have more extensive descriptions of all the different people who opined on the subject of Lesage gravity, as it was called, and all that kind of stuff. But so it's a pretty elaborate, and like I said, it's really not Lesage's gravity. I mean, he just took the other guy's papers, the French guy, who actually did know Newton, and Newton actually did like the model, but he didn't. Newton wasn't a guy to commit to things that he couldn't, resolve the problems that would exist. So there's these fundamental problems of mechanics, okay, like the pool ball argument. So if you make these things all hard, and so you have a hard thing hitting a hard thing, the problem is if the pool ball is standing still and you hit it, that means this one stays still and this thing moves. So you have a problem of this leftover bit. So you can't have a particle gravity that leaves particles that aren't moving in the universe, just sitting there, not moving. So that's sort of one thermodynamic, or it'll just end up being, like fog. It'll just create fog, and things will keep hitting the fog. You have to explain how you got rid of the fog. At least you have to explain it in more detail. I mean, I think you can fix that problem by just saying it wouldn't matter if something was stuck in between. If it takes no time between interactions, then it wouldn't matter if there was an extra interaction somewhere. It wouldn't matter if you had 100, if there was no time consumed in the passing on of the force, then you could literally, it wouldn't matter whether you lined up 10 cue balls or 100 pool balls or 1,000 pool balls, right next to each other, and hit one into the other by just hitting one. It would be exactly the same thing. It wouldn't matter to the movement of the force. And so there's all kinds of little subtle arguments like that have to be dealt with. Because if you have the thing hit and bounce off at a slower speed, that gets messy. So you have to explain how, if it's going to reflect off of, how the reflection actually takes place. Because that's essentially two forces. This going that way and then this going back that way. And so you have to explain that as an exchange of force rather than a communication of force. Let me go down to the bottom of this page. Well, I really wanted to do let me show the video some more, just to demonstrate that it just doesn't have enough, there's no detail in this explanation. But he certainly hasn't gotten to magnetism and all these other things that I think we're going to require the existence of charge, a charge model. So Nicolas Faraday, that's the guy who really thought of this thing first. He's the guy that talked to Newton. who was, actually they call him a friend of Newton's in the early days. And I think, Fadio got pretty disappointed later. And then apparently he joined some kind of wacky religion. They called it a religion. I don't know whether it was just a social movement, but whatever. But it was obviously not elitist friendly. And so that might have been why some people were turned off by him later. Who knows? But yeah, this is a line from the Wikipedia page. Conclusively discredited. Generally considered to be conclusively discredited. And when you look at the discredits, they're mostly 100, 200, 300-year-old discredits. The discredits are based on, presuming a model that has none of the depth of what we've learned about atoms. And so by their own standards, the people they're taking the opinion of 200 years ago would have mocked the idea of electrons inside of atoms, what keeps them moving. They'd be asking all kinds of questions, and especially about all the other 100 other particles that the modern standard model has in it. I'm sure there'd be a ton of critique about the invention of any one of those particles. And certainly if they got a chance to mock dark matter, that would certainly be mockable. So it is kind of funny to call it conclusively discredited when it hasn't really been discredited by a single really well-developed argument that acknowledges that you can that you could create something more sophisticated now than the original Fadio model of having to think of it as asteroids hitting the Earth. They didn't really have an understanding of this sense of this idea of like even a photon as being something moving at a constant speed, and having this being a conservation element, where energy goes in and then somewhere in the system energy comes out. None of those kind of rules have been developed. Alright, so streams of G1 particles, low intensity and no pattern. So this idea that there's an intensity difference doesn't really make any sense, because this is going to be a specific argument to what he's saying. So the idea of creating a particle that's moving at variable intensity, the only thing that these particles had that can be associated with intensity is frequency when it comes to light. So there's no intensity difference between photons if it wasn't for the fact that of the wavelength, because they use wavelength to say the shorter the wavelength the more intense, when the shorter the wavelength it just means you can put more of them in a smaller amount of space. So it's like shooting bullets fast. It doesn't make the bullets themselves more powerful, it just means you can shoot more bullets in the same amount of time. And so once you take frequency out, which he does with these G1 particles in gravity, they're not particles at a frequency, then how could they have intensity? How could they be something called low intensity? It doesn't make any sense. And the only way they could be is they'd have to have preposterously huge long wavelengths, way, way longer than the wavelength of, the radio waves, the longest radio waves, mile-long radio waves. And then you wouldn't have enough density of particles if they were that sparsely separated to produce any effect. Okay, anyway. So what else? So anyway, this is I guess I'll go back to that image just for the value of this simple little image. It's a little simplistic, but the force comes from the outside, and if you just imagine two bodies next to each other just like that, you're going to understand that arrows from the outside can't get to this body by the shadows. So the shadow this one would cast on that one, kind of a thing, which I probably should just draw and get to some of the points. So he goes into a bit of this, the point is that most of the stuff travels through and it's only a percentage that somehow hits the thing. But again, you have to recognize that it's more complicated than hitting, because then you create this whole heat problem. So the heat problem was a huge argument, say 200 years ago, against a particle model, because it was understood that you'd have all these bits flying off of the thing you're hitting. So kind of like the bullet argument, hitting and you're breaking off pieces and there's all kinds of stuff flying around. It doesn't, you have to use it as an absorption model. So you have to explain how it isn't that the momentum is destroyed, it's the momentum is absorbed and held, and then it's going to be released again in the future. So it's just being held as a direction for a period of time, and that's the acceleration, and that's the movement, causes the movement. But you have to qualify that, or you just run into the same problem where you get destroyed by these arguments about, like I said, arguments. He has a quote from the Wikipedia page, so he's obviously read it, and he should understand it, and he has to deal with the 43 different little arguments that are made on that page. Most of them redundant, don't get me wrong, but they're there. And some of them are really stupid. Some of them, I'm surprised the people who made the arguments hadn't recognized that they were trivial. Anyway, so this is his level 1 atoms. So he has 2 levels of atoms, 2 levels of particles, and there's just no explanation for how you deal with the existing evidence that exists in current physics for the distinction between neutron and proton. They're not the same particle. And the distinction between electron and photon, they're not the same thing. And it's just kind of, clearly electrons have the property of charge, photons don't. You can't just rename things like that without any explanation for how you deal with all the evidence that indicates those two things aren't the same thing. So it's really, and then this whole idea of creating little atoms and big atoms. That's for alarm. Be alarmed. Be alarmed. Yes, I'm supposed to wake up now, actually. But I don't think I'll choose to do that. I think I'll wake up later. Yeah. So anyway, I woke up way too early. Couldn't get back to sleep, so I said, oh, fuck it, I'll make a video. Alright. Alright, so, yeah, we'll go to, we'll just scroll down this Lesage. So that's the original Lesage drawing of Fatio. But it's not very good drawing in the sense that it doesn't really show all the stuff. But you can see there's lots of people here. Maxwell, Lord Kelvin, all kinds of people commented on it. Some of them liked it, some of them modified it. But yeah, nobody could make it work. It's like, Maxwell said, here then seems to be a path leading towards an explanation of the law of gravitation, which, if it can be shown to be in other respects consistent with facts, may turn out to be a royal road to the very, or whatever, Arsenio of science. They say that might have been sarcasm, but I don't know whether it makes any difference. Another statement. We have devoted more space to this theory than seems to deserve, because it is ingenious, and because it is the only theory of cause of gravitation which has been so far developed as to be capable of being attacked and defended. So that's the funny part, right? Is that there really wasn't any other theory of gravity. There's no competing theory. You're stuck with, there's essentially now there's two ideas, but there was really only one theory that gave you any explanation that created the inverse square law that made gravity work, except for just coming up with some notion that, oh yeah, it's just attracted by these rules. It's just the angels say so. So there was no material or physical explanation for gravity. And I'd argue there still isn't any other physical explanation. And really all we're dealing with is, what kind of arguments can be made to argue against it. Now, one of the funniest ones, so here are some of this drag issue. So this is one that's got to be dealt with. I've had to deal with it. That a particle field, but I think this is also an argument against ether, frankly, that a field of particles, you would crash into more as you got velocity. You would bang into more of this stuff hitting you in the front than would hit you from behind. And so you have to have an explanation for why things endure, to persevere, endeavor to persevere, in the sense that their velocity overwhelms that negative force. And kind of an obvious answer is, well, it has actually more velocity than you're measuring. It actually contains more force. It's actually going 40 miles an hour, and the drag has slowed it down to 30. And so you're seeing it going 30, and you're thinking it's going 30 miles an hour, but the wheels are actually spinning at 40. I mean, it actually has the thrust of the 40 mile an hour, and the drag is slowing it down. That's like sort of the obvious answer, is that it's actually got more force, and that's why it overwhelms the resistance, is because it's got more force than 30 miles an hour's worth of force. It has 40 miles an hour's worth of force, and that's why it goes 30 miles an hour, is because it loses 10 to that drag. Anyway, that would be the simplest answer. The truth isn't that far off from that, but it's a little more sophisticated. But anyway, so they use this aberration argument, which is kind of the idea. Okay, so this is a little bit sophisticated, in terms of conception. You have to think about it for a minute. But what their argument is sort of like, let's say they're saying, okay, we know now that gravity moves at the speed of light, so it's slow. It's not instantaneous, as Newton had assumed. Well, as Newton didn't really say. But anyway. And so they're thinking about it as if, okay, this gravity thing happens between these two bodies, and that's it. So they're sort of thinking that it's a communication that has to go between this and between this. And so you're saying, well, if it's slow, then say Pluto, which is very, very far away, and it would take a very long time for the gravity to get there, it would take so long that the planet would move over here. And so the gravity would be going where the planet was, not where the planet is. And so it couldn't continue its gravity communication because it keeps moving out of the gravity. Now, the irony of that argument is that's exactly why there's an inverse square law. The inverse square law guarantees when these two bodies make gravity, okay, by interacting, that both of them will radiate the effects of their gravity in this entire dimension. So in this entire half circle, the half of the tennis ball. So you gotta do it in half the tennis. You gotta remember to do the whole arc. But that's the inverse square law, right there. This is the inverse square law. Is the half of the tennis ball. Cut a tennis ball in half and put it on the floor, and that's the inverse square law. And so both bodies would be radiating their gravity equally in all directions, like a little porcupine. And so no matter where this body moves, it will get exactly the same amount of gravity will go here as was going where it used to be, and where it used to be over here, and where all these locations will get exactly the same. All locations the same distance away will get exactly the same amount of gravitational effect. So the very fact of the inverse square law is why gravity is weak, and why aberration can't possibly matter, because you can't move out of the gravity, can't get away from it, because it's being admitted. For every bit that comes in this way, one way, it gets admitted back this way, and that's the inverse square reciprocation, so to speak. And that's why gravity is weak, is because of that spreading of the reaction. The reaction doesn't go straight back and forth, so there's no direct communication of the effect. So what's happening, as I've tried to explain, is that the bodies aren't really pushed into each other, but you can sort of, try to. It's a little difficult to always illustrate these, the shadow effect, because you have to use lines and stuff. But you can sort of understand forces coming in from all these directions. So you have to just think of it coming in from all directions. And the secret is that you can understand that where this thing is the thickest, this force is likely to interact. And so this arrow that was going to go hit here, right? This is where it was going to go. It doesn't get there because it stays in here. It stays in here for a while, maybe a long while, but it stays in here, and that's the acceleration. Now, if it leaves, then it loses that velocity. But if it stays, that velocity is something that keeps increasing. So the velocity will keep going up as long as this arrow stays inside of here, in the sense of its effect, its momentum. And so the longer this arrow is delayed by being in this, so you just have basically a delay in time, dt we'll call that. So you have a delay in time, and the longer that delay, the faster this thing will start to go as it collects more and more of those arrows. And the same thing is happening here. So the force coming this way, this arrow never hits here. So this force ends up being stronger, more likely that this arrow gets absorbed in here and stays in here for a while. And so it accelerates towards the other body. So the two end up accelerating towards each other by an amount comparable to the other body's mass. So if this was the sun will move one Earth mass worth of the sun will move at exactly the same rate that the Earth moves towards the sun. So the two are really going to be moving equally towards each other. But just one Earth's mass of the sun is the only part that's going to be doing the moving. And it will be located at the center of the sun's gravity. And that's what creates the precession of the sun, that creates the precession of Mercury. Alright, let's see how else to explain this. I don't know if you need to, but I just mean you can get the shadow effect just understanding that this doesn't just bounce off. It's really getting absorbed by the Earth. So the Earth is collecting velocity. And it's called acceleration when it's gaining it. When it's collecting its acceleration while it retains its velocity. So if it doesn't give the arrow back, it'll be a permanent velocity. If it eventually shoots it out, then it was only temporary. Yeah. But if it collects it by exchanging it for something going some other way, which is my theory, clearly it's just an exchange. So it trades an arrow going this way for an arrow going some other way that it releases. So it can keep this one because it has a collection of them. It, it has arrows held and in all directions. They're all just stuck on a stick, let's say. And so when an arrow goes in, it can exchange. I'll keep another one this way, and I'll get rid of one going this way. And as it gets more and more arrows going in one direction, its speed, velocity, increases in that direction. really not that complicated. But these are all nuances. And then what really makes this work, to complicate it a layer, the layer deeper, was the realization that if you have these two polarizations of these force bits, and you understand that they're really moving the electrons and the protons inside the Earth and the Sun, those are the bits really being affected. Then you get a better idea of how the charges are sort of neutralized, because this communication is in this inverse square kind of way. So it's not like all the electrons in the Earth are completely opposite just electrons in the Sun. And so whatever bounces off here bounces back, bounces back, bounces back, bounces back. None of that can happen, because what's going to happen is whatever force goes over here is going to end up hitting something other than the electrons. It'll hit a proton. If it's a proton, it goes out. So it can't retain any of the push, repulsive pressures of charge, and it has this leakage, which ends up being the attractive force. The force goes in and it leaks out the side. So if you're a planet and you're going to get affected this way, and you're going to exchange an arrow that's hitting this way for an arrow that was going this way inside of you. So you release it this way and you keep this, then you're going to have an acceleration this way. What else did I want to say about that? There was another point. Shit. Oh, yeah, so this whole thing moves, and there's no force going this way, so there's nothing to reflect back, and so there's no pressure on this side. So you just have the outside pressure and low pressure in here between the two bodies. And so the pressure just keeps getting lower as they move towards each other. The more this one moves, the lower the pressure goes. The more this one moves, the lower the pressure goes. So they just keep lowering the pressure between them by absorbing the energy that would have hit them. So the more of these arrows this thing collects, and the more of these arrows it gets rid of going the wrong way, the lower the pressure gets between the two, and that's the attraction that you see as gravity. Alright, there's a few more elements to it, but these are the basic arguments. The drag argument just has to do with the velocity argument. Why do things keep moving? And they keep moving essentially because they've captured this force and they are holding it. They're not giving it back. So the little engine that could goes in, and the little engine that could just keeps cutting along. And that adds up in the sense that you end up deforming the matter. So matter that would be evenly distributed, like you could draw it with a bunch of equal lines, becomes unevenly distributed in that most of the lines are going one way and has very few going the other ways. And so if these were all just considered arrows, it would be going this way. But that's manifested in the form of electrons and protons having to be moved. And electrons and protons have to keep being hit to keep moving, because they can't retain. They don't have a structure to retain a velocity. So when they gain an imbalance, they don't keep it, because the external forces from the side are going to keep converting it to a neutral. So the force really has to be between the electrons. So when one of these earthly bodies, the big things, is absorbing, when it's absorbing these external arrows, it's really absorbing them between the electrons. So it's collecting them between electrons. So instead of having one arrow between these two electrons, now there's two. And then there's two here. And what there really is is there's protons at the corners, and the protons are essentially, when the force goes through the electron, hits the proton, goes, turns 90 degrees, hits the proton, turns 90 degrees, and all the electrons are on this side, and there's no electrons on this side. So the force just goes really fast through here. Well, it's not any faster, but it doesn't move any matter going this whole process doesn't move anything. And this process is moving all the electrons. So all the electrons move forward. And that just creates your lopsided circle, which essentially just says, you keep spiraling, through space in this kind of manner. So yeah, that's. So I have to make just solid graphics, just do some of this here stuff, and I want to make some animated GIFs and stuff like that, but it all takes time, and I just haven't had the time yet to. Got to do it. I mean, I hate wasting time on the, drawings, but I guess I have to. So anyway, I guess I'll leave it at that. See, it's like one of the arguments is energy absorption. So there really wouldn't be any issues with heat because you're not destroying anything and you're not breaking anything. You're just exchanging. You let a piece of momentum go that way and you lock in a piece of momentum going this way. You're just exchanging. And so there's no heat. Alright, so enough said, and probably. But yeah, there's a lot to go through in terms of the argument, but there's really there's nothing, the arguments are all really old arguments. There's not like some sophisticated new modern argument against this theory, and all the arguments are as simply explained as this inverse square law thing. I mean, the aberration would be that argument shouldn't even have been made. It's so bad. And I think that was actually made by Darwin, Darwin's grandfather or whatever. And it's just not a very good argument if you understand the inverse square law. So anyway, yeah, that's enough, I think. Why there is an inverse square law. There's an inverse square law, quite obviously, in my opinion, because gravity isn't direct communication. The communication ends up being diluted. Your message goes in, the return message comes out in a bunch of little pieces going all directions. That's what weakens the force. Alright, until next time and such.